Okay, hello everybody. Look, today, since I'm not at school today, what's going to happen is I'm going to give you a series of questions, and you are going to work on these questions, and I'm going to instruct the teacher to stop this presentation so you can work on your questions. Then after a few minutes, I'll ask them to turn it back on, and you can then check your solution. So the first thing we're going to do today is calculate the intersection. I'll write this down. Oh, that's in red, so it's a good start, isn't it? So let's just make this a nice colour of that. Okay, so now I've got this. So it's the intersection you're going to calculate the intersection of f of x being equal to 2x squared plus 9x take 7 and g of x, which is our second function, which is going to equal negative x squared plus 4. Now, for you to do this, you are going to have to determine a strategy. Now, just because I'm a nice guy, I am actually going to tell you what that strategy will be. Okay, so the strategy for this case here, number one, will be quite simply sketch it, which means sketch f of x and g of x. Now, I suggest you use Desmos for that to get a nice accurate picture. Number two, you are going to solve it. Now, I'm not going to tell you yet how to do that. You should know how to do that. And the third part of this is quite simply you are going to check your solution against the graph. Well, against the sketch, I suppose. It's not really a graph, it's a sketch because you're not actually doing much. Now, when I say solve it actually means something very, very unique. Solve it means a point, x and y. Most people only ever do the x, they forget about doing the y. So here's your task. You are to find the intersection of f of x and g of x. I'm going to give you 5 minutes to do this. 5 minutes. In that time, this will be stopped, and your teacher, I'm going to ask your teacher to stop this, and then you will then solve it. After 5 minutes, the presentation will continue. So I'm going to ask the teacher, stop this now. Okay, now, here we go. So you should have been stopped, and now you should have been continuing on with your work, and you should have had a solution by now. So let's just see your solution. As I said, step number one was to actually graph it. Now I'm going to do a pretty dodgy graph here because I'm as inconvenient lucky as you. I don't have actually Desmos available to me to sketch it nice and neatly. But I do know that the graph looks something like that. That one there is g of x, because it was negative x squared, so it's upside down. And the f of x looks something like this. Now I want little arrows on here because, in fact, I should put arrows on all these places, indicating that it doesn't actually stop. That's f of x. Now, therefore, the points that I'm looking for are actually here and here. They are the values that I'm looking for. So I've done my strategy number one. Number two is to solve it. So what I'm supposed to do, I'm supposed to let f of x equal g of x. Now, by doing so, I'm going to have to do this. Therefore, oops, what's going on there? 2x squared plus 9x take 7 is going to have to equal negative x. What's happened there? Negative x squared plus 4. Now, by getting all of this part here and bringing it across the other side, how about we do this again? Getting all this and bringing it across the other side, I end up with 3x squared plus 9x take 11 equals 0. Great. Now, when I think about my way which I can solve this, all of you guys here will most likely want to use the quadratic formula, if I'm correct. So, since you like using it and I don't, I'm going to have to use it. So to solve the quadratic formula. Now, the quadratic formula in this case, A is equal to 3, B is equal to 9, and C is equal to negative 11. So, using our rule, x equals negative b plus or minus the square root of b squared minus 4ac over 2a. I can now go ahead and substitute that and work it out. Well, just lucky I can, because I can now do this. X will equal negative 9 plus or minus the square root of 9 squared minus 4 times 3 times negative 11. And that's all over 2 by 3. Right, now a bit of calculation here to do. Negative 9 plus or minus 81 plus, and that's going to work out to be 132 over 6. If I keep going, negative 9 plus or minus the square root of 216 over 6. If I keep going, negative 9 plus or minus the not the square root, but the value comes out to be approximately 14.6. That's one decimal place. That'll do for me. Over 6. Now, once I get that part, therefore, x will equal negative 9 plus 14.6 over 6, or x will equal negative 9 minus 14.6 over 6. Now, when you work that out, x comes out to be negative 3.93, or x equals 0.93 recurring. Right. But that's not the solution. The solution is to find the point of intersection, and the point of intersection has an x and a y. Now, therefore, I have to get these values here, that value there, and that value there, and substitute them into either g of x or f of x. Now, I know I've always said avoid using negative numbers, but g of x is a much simpler equation to use today. If you don't like g of x, always go back and use f of x. So this time what I want g of negative 3.93. And what it means is negative of negative 3.93 squared plus the 4. And when I do that, I end up with 11.46. Okay, now in fact, what I should end up with is not that number at all. Not 11.46, but negative. Oh, won't go, the negative 11.46. Now that's that one. But then I also have to do for the other value. So I have to work out g of 0.93 recurring. And that's going to equal the negative of 0.93 squared plus 4. And when I do that, I get 3.135. Therefore, my points of intersection are 0.93, 3.135, and the other one is negative 3.93 negative 11.46. And if you've done that correctly yourself, you will have the same answer as me. Beautiful, just like myself. Now, from here, very shortly, you can replay this if you like. It's because this is on Edmodo, but I'm going to give you a question very shortly for which you can do the same process again. Okay, is the 5 minutes up? Well, if it is up, then we had better get going, but I've just lost my pen, so I don't know how I'm going to write with. Aha, found my pen. So let's get cracking. Okay, since the strategy for this one, okay, I haven't given you a question yet, I better give you the question. This time the question is going to be, I want you to sketch f of x equaling 3x squared minus 7x minus 6 between the values of negative 1 and 3.5. Now, for this to do this, you are going to need a strategy again. Now, the strategy is going to be quite simple. Number 1, sketch it. Now, that might seem strange, but I've actually asked you to do it. I'm not going to say sketch it using Desmos, because as mathematicians we are smart, and therefore we are going to actually know what the answer should look like before you even start it. And secondly, you can check yourself as you go. So sketching it means, realistically, up here what I really want you to say is using maths. Okay, so it's not just getting the iPad to do it. You actually have to check yourself and be able to show people that you know what you're doing. So number 1, sketch that. Number 2, find the roots of the equation. Now someone in the class is going, what the heck are the roots again? Well, the roots are when the function equals 0. That's right, we all remember that now. Good. Number 3, find the y-intercept. Now, where is the y-intercept? The y-intercept is on the y-axis, remember? So that means the whole function needs to equal 0. And since we have a quadratic, that looks like it's going to be a quadratic formula. Number 4, find the turning points. Well, in this case, it'll be 1 because of the quadratic. Now, I heard some people already saying, what is Mr. Moore talking about? Well, turning point is quite simply the x value is negative b over 2a. And I'm telling you now, we did this, but 99% of you have forgotten that. So isn't that a sad case? But guess what? You're going to have to do it anyway. And number 5 is check your answers. Oh no, sorry. Check not your answers, but check the domain values. What domain? Domain are your x values. So, in other words, what is f of negative 1? And what is f of, I still wrote 3.5. Let's just write 3.5. That'll make it a bit easier for you. Okay, that is your strategy. So, number 1, sketch it using Desmos so you know what you're trying to find. Number 2, find the roots, let the quadratic equation equal 0, solve that. You should get 2 answers, possibly. Number 3, find the y-intercept, let the function equal 0. That's not right. That is incorrect. You don't let the function equal 0. How about I just go back and say, how about I just rub this out? To find the y-intercept, what I actually have to do is let x equal 0. That is now becomes right. So get rid of that now. Did anyone pick it up? Bet you didn't. But I know who would have. Would have been the person sitting in the middle of the 3rd row. Alright, and then we go find the turning point. Now remember, the turning point is where it actually turns around and goes from a negative gradient to a positive gradient, or the lowest part on the top. Sad face, the bottom of the curve, happy face, the top of the curve. And the last thing, check your values at the end, your -1 and 3.5, to see where those values are. Okay, that should take you about 6 minutes. So I'll give you 6 minutes to do that. Ding, 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 ding. 6 minutes is up. So let's do it now. So let's look at the roots. This is where we say f of x is going to equal 0. So what do we got? 3x squared, take 7x, not plus, but minus 6, that equals 0. So, what two numbers multiply to give you -18, but add up to give you -7? I reckon 9 times, or how about -9 times 2? They multiply to get -80, and they add up to give you -7. So, just to make life painful for you guys, I am going to factorise this, because I like to factorise it. Don't like. If you use the quadratic formula, that's fine, but let's see what would have happened. 3x squared, take 9x plus 2x, take 6 equals 0. So therefore we get that one and that one there, and we have 3x is common, so you're left with x take 3 plus the 2, and you're left with x take 3 equals 0. So therefore x take 3 in one bracket and 3x plus 2 in the other bracket equals 0. Therefore either x take 3 equals 0 or 3x plus 2 equals 0. So therefore x equals 3 or 3x equals -2, x equals -2/3. Now if you hear noise in the background, that's Hannah. She's being a dog. Alright, so we have now found our root to the equation. Right, next step is to find the y-intercept. I can't get this right. I-N-T-E-R. Okay, and to do that, you'll let the x value equal 0. So, what have we got? We've got f of x equaling 3x squared take 7x take 6. So f of 0 is going to equal just -6, because that disappears and that disappears. So I put 0 into it. Beautiful. There's my second value. Now the third thing I needed to find was the turning point. So I was going to write t dot p, I'm going to write x now, because turning point x is -b over 2a. Now, remembering from the original equation, I better write that up here so that we don't forget it. Oh no, it's up the top there. I can see it up here. That b was equal to -7, so -b is actually 7, because negative of a negative is a positive, over 2 times 3, so I get 7 over 6, which equals 1.16 recurring. Now that's my turning point x. I also need to find the turning point y. So I'm going to write t, p, y, and that just equals f of 1.16 recurring. So f of 1.16 is going to equal 3 by 1.16 squared minus 7. I'll tell you what I'm going to do. I am going to just go to a brand new page and do this. So f of 1.16 recurring is 3 by 1.16 squared, take 7 by 1.16, take 6, and that will give me magic, -10.0 0.83. Now, if you didn't get the same answer as me, guess what? You're wrong. Now, last thing is to check your domain values. Now, domain stands for the X numbers. Now, they were, by the way, they were negative, -1. Let me see, I can't remember. Yes, -1, X, 2, 3.5. So, all we have to do is go f of 1, and magic, gives me 10, and f of, now I was going to put 3.5, substituting that in and getting the right answer. If you don't get 6.25, you've done a calculation error. What does this mean? Well, go to my last page. I've got a nice, lovely little graph there. Love it. I have a whole series of points. For example, when f of 1, I have, now, that's not right, just hold on a tick. Now you would have noticed I've just jumped back a screen, because it's f of 1 I had to calculate, and it should have been f of -1, and which means this answer is not 10, it's actually 4. So what I really do, I have points of -1, 4, and points of 3.5, 6.25. So what I've done is I've got a whole bunch of points in which I can now sketch on. So when it's -1, I get a 4. When it was 3.5, I get 6.25. So it's somewhere up here. So I'll put big crosses, that'll do. There and there. I now also remember my roots as being, what were they? 3? No, it can't be 3. What's going on here? 3, as I said, and -2/3. So we're going to go through that point there. So I'm going to put a little arrow up there. -2/3. Now, so therefore, the last thing I've got was my turning point, which was 1.16, and its corresponding y value was -10. It's going to be somewhere down here. I haven't drawn this to scale at all. -10 point, how about I might make that a little bit bigger. -10.083 there, which means it's somewhere around about here. So now I have 5 points in which I can join up. So being the skillful sketcher that I am, let's see if I can do this. Looking magnificent, Mr. Moore, and I go through, and I just realised I forgot one point. Anyone know the point I forgot? The y-intercept. And the y-intercept was there, and if I remember correctly, that value there should have been -6. So in fact, I end up having all of my points that I was to calculate, and you'll notice that my graph does not continue on here and here, simply because I said I wanted to go from -1 x to 3. There we go. You got that right? Give yourself a big smile. If you got it wrong, give yourself a big smile and learn from the experience.